All right, section 5 here. Now, in the last one, we talked about solving. Here, we're going to look a lot more at factoring. Now, on the ones that we factored earlier, you'll notice that the piece that we factored was all a monomial, right? That was all just a monomial coming outside. Now, we're going to be splitting a trinomial into two separate binomials. All of these problems are going to look something like ax squared plus bx plus c, right? And we'll notice that there's like a 1 there, right? It's just there's not a number there, it's just a 1. That makes these problems considerably easier. In the next section, if I remember correctly, yeah, we have the a sitting out front. And that makes the problems quite a bit harder, a little bit longer. So here we're in the easy stuff still. Looking at what they've got here, they say x squared plus bx plus c can be factored to be x plus p and x plus q, where q plus p is b and p times q is c. Now that's awesome, but I want to see this in numbers. So let's actually let's take this x plus 1, x plus 5, let's take to the side here. X plus 1, x plus 5. All right, and I just want to multiply this out like we've done, and maybe we'll be able to see a pattern. We get our x squared plus 5x plus 1x, and then what is that, plus 5. These middle guys add up to be 6x. So we have x squared plus 6x and then plus 5. Now something to notice, is that 5 times 1 is 5, right? 5 times 1, here, maybe I'll write that down. 5 times 1 is 5, and then 5 plus 1 is 6. So on all of these problems, you're going to want to multiply to be the last piece and add up to be the middle piece. That's going to be our pattern here. Let's look at this in example 25. Now again, we said we want to multiply to be the last piece. So multiply to be negative 10 and add to be 3. So this is the way that I approach the problems. I think about doing a little bitty factor tree right there. I kind of break up the negative 10, and we might be able to think of what combination adds up to be 3. But if you can't, you just start listing stuff. What two numbers multiply to be negative 10? Well, 10 times negative 1. Negative 10 times positive 1. 5 times negative 2. And then negative 5 times 2. I'm thinking that's the only ways to make a negative 10. So now I start thinking about what happens when we add them up. Well, 10 plus negative 1 is 9. Negative 10 plus 1 is negative 9. 5 minus 2 is 3. Oh, that's what we wanted, right? We wanted a positive 3. So this is our combination that we want. And just to show this last one, negative 5 plus 2 is going to be negative 3. And that's not what we wanted. So we're going to want the numbers 5 and negative 2. So we open up some parentheses here. In the first spot, we get an x, because that's the variable we're dealing with. And then we have a plus 5 and a minus 2. All right, that's the process there. That is our answer. Just 2, I want to check our answer. I want to multiply it back out. So let me we'll box this in. That's our answer. But then I want to multiply it back out. X times x is x squared. X times negative 2 is a negative 2x. Then we have 5x. Then we have negative 10. These two middle guys add up to be 3x, which is what we started with. We started off with the x squared, 3x, and negative 10. So that's our process that we're going to need to be doing. We multiply to be the last piece, then we add up to be the middle piece. So right here, we're looking for things that multiply to be 18 and add up to be negative 11. Now, let's think about this. We have two numbers. They're multiplying to be a positive, right? Positive 18, but they've got to add up to be a negative. That means they're both going to have to be negative numbers, right? So let's think about negative 1 and negative 18. Well, that doesn't work out. That's going to be, what is that, negative 19. we'll say -2 and -9. Well, that adds up to be -11, and that's what we wanted. So this is it right here. So again, the reason that I picked negatives is because this 18 is positive. And if you're multiplying two numbers and you get a positive, they either both have to be positive or they both have to be a negative, right? Because the double negatives give you a positive. Because we're getting a -11 when we add them up, we know they've both got to be negative. Now, -2 and -9, we break this up and we say, well, this is x minus 2, x minus 9. And that is our answer. If you want to check yourself, you don't have to, but if you want to, we'd multiply and we'd get x squared minus 9x minus 2x plus 18. These middle guys add up to be -11x, which is what we wanted. So there we are. That is factoring trinomials. Let's look at another one. Oh, is this the exact same problem we did earlier? It is the exact same problem. Let's just go ahead and skip that guy there. Next page. We're wanting to break up the -16 and add up to be -6. Now, if they're going to multiply to be a negative, then one has to be positive, one has to be negative, right? And I'm going to try to think this through in my head without having to write a bunch down. I'm thinking -8 and +2, right? -8 times 2 is -16. -8 plus 2 is -6. So that's going to be the combination we want. Now, if you wanted to, you could list all these out. Okay, if it wasn't obvious what they were, you would want to list them out, and then you'd be able to find it. Now, just as a side note, these ones here, these problems, they're set up such that they will factor. Okay, there are some of them that they just don't work out. So if you think about something like x squared plus, I don't know, 1x plus 2, right? That's just a side note, just a separate problem. 2 can be made by 1 times 2 or -1 times -2. There's no way for them to add up to be a 1. Okay, so I just want us to recognize that these problems here, these examples, and then also the homework over this section, they're set up such that they work out. Okay, in the future, you might get ones that don't work out, and you'd have to be able to recognize that, well, this doesn't work out. And then we'll be learning other methods to solve after that. But going back to 28, we found out that it's a -8 and +2. So we'll have y minus 8 and y plus 2. And that's that. 29. We're looking for two numbers that multiply to be -40 and add up to be -3. I'm thinking 5 and 8. 5 times 8 is 40. We want it to be a -40, so one of them needs to be negative. And they add it to be a -3, so it needs to be the bigger one. So 5 minus 8, that gives us -3. That works out for us. So it's going to be n plus 5, n minus 8. And there we are. All right. Is number 30 our last one? It is. Things that multiply to be -24 and add up to be +5. Well, I'm not seeing it right away. We'll say 2 and 12. Well, that can't give you a 5. I guess one of them would need to be negative anyway. What could we say? I think it's 8 times 3. Which one's going to be negative? 3 would be negative, right? 8 minus 3 gives us the 5. Yep, there we are. So it'll be d plus 8, d minus 3. And that's that. Alrighty. Whenever you get stumped like I did just now, right, I couldn't think of this. I don't know why I couldn't think of it, but I couldn't. You just start thinking about what all can multiply to be 24. Okay? And if you wanted to list out 1 and 24, 2 and 12, 3 and 8, and you could go on and on. Right? There's a few other ones as well. That's not a bad idea to do that, okay? All right. That is it for this section here. Things to remember. This works for trinomials with a 1 hanging in front of the x squared term, right? With a 1 as its leading coefficient. You look for things that multiply to be the last, right? Multiply to be negative 10. Maybe I'll just write that out. Oops. Multiply to be the last, add to be the middle. That's what we're looking for. Multiplying to be the last term and adding up to the middle term. All right, that is section 5.